yeah, we'll start with the very first question. Here, we are given a sorted array. And we have to find a pair with sum equal to x. Now, we don't want those values. What we want as an output is true or false. Okay. So, guys, just for hit purpose, like I think most of you can solve this question using naive approach. So, guys, the time complexity for this will be big of n square. Okay. We'll try to use the approach of 2 pointers here. So this is the basic idea how we solve this question. This is the entire logic. So yeah, so this question is clear. It makes sense to everyone how to solve this, how to approach this. So yeah, we'll start with the very first question. Here, we are given a sorted array. And we have to find a pair with sum equal to x. We have to find a pair with sum as equal to x in our sorted array. So what I mean by this is, let's say we have something like 2, 5, 8, 12, 30. Okay. And we have to find a pair whose sum is equal to the given value. Let's say x for now is 17. So since you can see here, the pair will be 12 and 5. So this is the given question. You will be given an array which is sorted. You have to find a pair whose sum is equal to the given value x. Now, we don't want those values. What we want as an output is true or false. Okay. If the pair exists in an array whose sum is equal to given value x, then you return a true. If it doesn't exist, then you return a false. So yeah, this question is pretty straightforward. So guys, just for hit purpose, like I think most of you can solve this question using naive approach. At least try solving through the brute force. Second thing is for optimizing it, you can see like how we can optimize it. We have to take some benefit of the idea that somewhere the array is sorted. Are we getting any benefit out of it? So you have to think in that way to optimize it. So we have mentioned we want to return either true or false. So that's why we have kept a bool as a return type. So let us say bool is pair. Let's say it takes 3 elements, the array, the length of the array, and the element that you have to find. Okay. Now, for we want to check the pair, correct? So let's run a loop of I equal to 0 till I less than n, and then I plus plus. Then again we run a loop, and this loop will be for j equal to I plus 1, j less than n, and j plus plus. If array of I plus array of j is equal to x, then return true, else return false. Okay, pretty much simple solution. Guys, but I notedly make one mistake in my solution. Can anyone point it out? What is that mistake I made? So yeah, that was one thing wrong. The I will go. So I will come back to you, Puneet and Veda. I will see what where you guys are having difficulty understanding. But yeah, see, that was very pretty basic, correct? Like I think you guys not looked it properly. So see, j is for I plus 1. If I will go to the less than n, then the last loop when it will run, it will go for array index out of bounds or something, correct? Because j I plus 1, it will never go. It's nothing because array is only till n. So since we are doing I plus 1, we have to go till n minus 1. That is one thing. Cool. Yeah, these are small things, yeah. So normally, but when we code, like even in any online assessment or something, we just start from 0 and we go till n. This is what we normally do. But you have to keep in mind, if you are keeping the value of j as I plus 1, you have to always keep the higher value of I as n minus 1. And it will be something which will be used in a lot of questions. So keep note of this. Other thing was like this return thing, correct? So if we have returned here an else part, so for the very first condition, if it is not, let's say very first condition is x2 plus 5, 7. 7 was not equal to 17. And at that time only it would have returned false in the else case, which is not the case. We have to find for all the possible combinations. Then we have to go out of the loop and then return false. Even though more or less even the last time code was same, but by just removing these two braces on top of it, it was entirely we are getting the wrong answer for most of the test cases. Correct. So these were small things I want all of you to keep in mind. Now, can everyone tell me the time complexity for this? So guys, the time complexity for this will be big of n square. Okay. So not doing a proper diagram for this as well, but just for having the idea. So I want everyone to think at least for the naive approach, correct? Because if let's say a very difficult question comes and it is a very new variety of question, then at least you should be able to solve through naive approach in the interview. It will give confidence to the interviewer that at least you understood the question and you can solve it. So even in some cases it can give you a lean hire or something. So it will be good other than not solving it. So solving it in a wrong way to optimize approach better is to solve it the naive approach. Even if you don't solve it in the interview, just give the idea to the interviewer that this is what you can follow and then you will optimize it. No need to write the code, just explain your approach to the interviewer. Then you can go ahead coding in the optimized way. This is how we follow. So yeah, so this was 2, 5, 8, 13. So what happens? 2 finds all combinations with all the elements on the right side of it. So it was 2, 5, 2, 8, 2, 12, 2, 30. Correct. None of the combinations sum was equal to 17. If you see, it was 7, it was 10, it was 14, it was 32. Similarly, when we are at this 5, 5 now happens to have all the combination with all the elements again on the right of it, because I is now 1 and j is I plus 1. So j is 2. So 5 gets added with 8. This 13 is not equal. Again, another combination of j. 5 with 12. It becomes 17. Correct. So this is how we are getting the answer. When we get the 17, we return the true. Let's say if we find all possible combination, we don't get the answer. Then after both the loops before the closing of the function, we'll just return a false. So this is small diagram for this. Now let us see, we want to optimize this, okay? What should we do? So let's say we have something like 2, 5, 8, 12, 30, okay? We'll try to use the approach of 2 pointers here, okay? What we want to do actually is we want to have 2 pointers, one at the very starting and one at the very end. So how we want to do it is we want to do sum every time. So let's say we have the pointer at the starting, we have the pointer at the end, and we do the sum. So every time we do a sum, there will be 2 possible scenarios. Either the sum will be greater than the value of x or smaller than the value of x. Correct. Either the value of sum will be greater than the value of x, smaller than the value of x, or the third scenario is sum is equal to value of x. Equal to. If this is the case, that is very simple. We return a true. Correct. That we have got the sum. In other cases, let's say the value of sum is greater than x. Correct. In that case, since we know that our array is sorted, okay, then what we will do? If the sum is greater than x, that means we have to remove the element which is on I and j. We have to change that element which is of higher value. So in that case, we'll decrease the value for j. We'll do j minus minus. So let's say 2 plus 30 was 32. Why we did j minus minus? Because after that j will come to 12 and now the sum will become 14. So whenever the sum is high, that means we have to decrease the sum. For decreasing the sum, what we can do is that we can decrease the value of j, because j is at the rightmost and this is sorted array. So obviously the rightmost element will always be the largest in the array. So whenever we want to find sum greater than x, we want to decrease the value for sum. So we'll always do j minus minus. Another scenario, let's discuss. When the value of sum is lesser than x, in that case, what we want to do? We want to just increase. If sum is less, that means we want to increase the value of our sum. Correct. In that case, we want to do I plus plus. Why I plus plus? Since we know we want to increase the value of our sum, and we are the leftmost element will always be the smallest. So if we can increase on the right side, correct, then our value of sum will increase. So this is the basic idea how we solve this question. This is the entire logic. So now, yeah, let us see the code for this. So let's say we have this. So let's say we take 3 elements similar to what we did previously, and add it, n, and x. Now, as I mentioned, I will be 0, j will be n minus 1. Okay. Just want to do while I is less than j. Correct. So if our array of I plus array of j, if those two elements sum is equal to x, that means we are at this case, the third case. We just return true. Everything is good at our end. We have got the answer. Else, what we want to do? We want to do a I plus plus. Or let's write it as, because we have 3 conditions. So let's write it as multiple. Let's say else if array of I plus array of j. So we want to do I plus plus. That means it should be lesser than x. And the else case, if it is not equal, it is not lesser, that means it will be greater. In that case, we'll do j minus minus. So this will be the code for this. Let us see a small diagram for this. So let's say, we'll take any example. Let's say we have this 2, 5, 8, 5, 8, 12, 30. The value of x is 17. Okay. So how is our approach working? Let's see. So initially, what happens is the value of our I is 0 and value for j is n minus 1. So n is 5, n minus 1, 4. This is our initial value. Now, at the very first time, what will happen? I is less than j, correct? You can see here. We see array of I plus array of j, which is 2 plus 30. So at first time, what we see? 2 plus 30. It sums as 32. Now this 32 we see is greater than 17. Correct. So it will come under this case, this else case, and will decrease the value of our j. So j now becomes j minus minus. So j now becomes 3. Now we'll go for the second case. What happens in the second case is now we go to the loop. I is still 0 and j is now 3. Correct. So we are now at 2 plus index at 3, which is 12. So it is now as 14. Now the value of this 14 is lesser than 17. So we go to the else if case because the array of I plus array of j is lesser than x. So we do a I plus plus. The value of our I now becomes 1. Now let's talk about the third case. In third case, what happens? I has now become 1, we are at 5. J is still 3, we are at 12. They get 12 plus 5, 17. Now this 17 is equal to this. Correct. Whatever is the given value for x. So at this point, we get our answer. We'll just return true from here. So yeah, so this question is clear. It makes sense to everyone how to solve this, how to approach this.